to you about the Irods functionality within the Grassroots infrastructure. So, as part of the background, Grassroots is part of the Wheat Information System, which is a G20 initiative to try and increase food security around wheat. And it's a global initiative, and the idea is that it's trying to hook up researchers and farmers and breeders across the world and try and share data and knowledge. So we're part of that. And some of the challenges we have, because it's a global situation, we've got geographic disparity, so we've got to make sure that we can access all the researchers and they can access all the data. Code reusability, so if you've got independent research groups, we might often be doing the same thing over and over, so you're trying to save them time. A big one is data interoperability, so every research group or every breeder might be storing their data in a particular format, and how you make that all coalesce together and make it usable is difficult. And also with service interoperability, so for services I mean applications that you can run across the data, and I'll explain a few as we go through. And it's trying to how you can hook up all the services to access all the data as possible. So our goals largely revolve around, three things. So the first is with data, we try and make it as reusable as possible and try and federate it. Sounds kind of Irodsy. And we also try and do a similar thing with services, trying to integrate the services as possible, as much as we can. And a big deal is to try and make it as user-friendly as possible. So we have obviously varying levels of users, and a lot of them don't want to be presented with a great big web-based form. They want a very simple, like Google type approach. So we try and do that. So this might be obvious to a few people, but I'll put it in there. So we work as a server-client system. So we've got, as a client would typically, when you request a web page from your computer or your laptop, it makes a request to a server and pulls back some data. And similarly, if you have a dynamically generated content, such as a text search or blast, as I'll describe in a bit more, then you'll have a service that will access some back-end data, produce some results, and send that back. So we started by thinking, okay, what we can use for our Grassroots server infrastructure. And our initial port of call is using Apache. And the reason for this is it's very robust, very widely supported, and basically a lot of the stuff that you want to do, they already do it, so you don't have to bother writing it. So that's a good place to start. So with things like authentication, SSL, and everything like this, and the community is really big, so it's a really good place to start with. So we took our Grassroots core libraries and created a Grassroots Apache module to hook up between the two. So effectively a small little module that sits on the Apache server that then talks to the rest of the Grassroots system. So the Grassroots libraries are kind of like the core boilerplate code that we try and make sure that developers don't have to reproduce. So it's like lots of networking code and how we define our servers and services and parameters and trying to standardize all these. And also the ability to read and write from different data stores. So we have the ability to write local files, Irods, Dropbox, Google Drive, and so forth. So they're our core libraries. And then the actual stuff that users care about are the services. So these are the things that actually do scientific analysis. So we have two different types of services. So we have what we call heavyweight services, and this tend to be where a programmer will actually write something. And we have a services API that, as long as they fill that in, they can do whatever they want and interact with the system. So we've got a few services listed there, so Blast, Irods, FieldPath, Genomic, and SAMtools, which I'll explain as we go further on. But for people that aren't programmers, we also have the ability to create like scripts. So these are structured text files that can use the Grassroots libraries to perform simple tasks. So we often use this to wrap up various different web search services that you might want to actually call and integrate into the Grassroots system. So our Grassroots architecture, we're completely platform and programming language independent because, of course, we can't go to these different research groups and say, you must use this language, you must use this. We've got to try and make it interoperable. So in the same way that all web pages are HTML that are just sent across the systems, we have a JSON schema that defines all the servers and services and the parameters and how you run them, and that just goes back and forth between the servers and the clients. We work on a distributed information exchange. We don't want to be the central hub globally. We want it to be distributed across the web. We don't want to be a data warehouse. We don't want to take on anyone's data or services. We're happy for everyone to own their own data. So we work on a system of interconnected web servers and services which transmit messages using our JSON schema and communicate through a standard REST API. So typically, if you imagine a situation where a researcher or a breeder or someone wants to log into, say, our servers at the Earlham Institute and run, say, a BLAST service, which is, BLAST is a way of finding areas of similarity between genetic data. So typically, they'd go in and make a request and they use a parameter and run it against the database that we have there. But they also might want to look for the same kind of thing on a database on a different system. So in this case, University of Bristol, which is one of our partners in this system. So obviously a problem you have there is that they're having to log into two different systems twice. They might put in the wrong parameters or different parameters, and they've got to collate the results together. So you're prone to human error, and you're also making it time-consuming. So how do we try and solve that? So by having our Grassroots servers connected together, they become a set of distributed services, so that if you say log into the Earlham Institute, you see all of the services that are available at our place, but also all the ones that are available at Bristol. And similarly, if you log into the University of Bristol, you get exactly the same list. Imagine it, if you're talking in Irods speak, it's like federated zones. It doesn't matter what entry point you use, you see the same list of services. But we then go, the two red cogs there, which represent the two BLAST services, still means the user has to put in the same parameters twice. So what we've also done is made it that duplicated services can get amalgamated, so the services themselves are smart enough to go, oh, on the same service, the only actual difference between us running is what data we're running against. So you log into it, what you actually see is a single BLAST service with a list of all the different databases from all the institutions. So that way the user doesn't have to worry about typing in the same thing twice. We're trying to make the user's life as easy as possible. Of course, under the hood, what actually happens is messages go back and forth between the different systems, but yeah. So once you've got say you run a particular service, you often, especially like a workflow type situation, you might want to take some values from the output of running one service and then use that to run another. So you've got exactly the same problem of human error of cutting and pasting and the time consuming. So we have the ability that services are able to extract semantically some data from running one service. So we have this is a snippet of running a BLAST search, and there's some information there which basically said which database it ran against and which scaffold name it is. So each database, each genetic sequence is separated into chunks called scaffolds. So when you have a hit, it exists within one particular scaffold, and we have a service called SAMTools, which was on the slide earlier, which, given for a particular hit, can pull back the entire scaffold in which it's contained. So this is using our desktop application. So because everything's communicated in JSON, we have both web-based front ends, which is dynamic, but we also have a Qt-based desktop application client. So we have the idea of workflow from there. Now, in terms of data interoperability, we've tried to do semantic metadata support. So we use various ontologies to try and hope that we can then join up the data between the different institutions. So we've got some example here. So I'll get onto it in a bit, but the field pathogenomics service has data to do with map locations. And if you can see the items in red, well, what we've got are taken from schema.org, various different data types defined for these parameters. So we know that, for instance, southwest bound is a geo-coordinate and it has a latitude and a longitude. So that other consumers of data can pull this in and actually start to do stuff with it. So we use various schemas. So schema.org, which is a general schema, but, along with more sort of bioinformatics specific schemas like sequence ontology, EDM, and FALDO. So we'll use as many ontologies as we possibly can. And finally, we come to, in terms of the architecture, how it is to add a service. So we try and, again, make that as easy as possible. So installation is as straightforward as just copying a shared object, like a plugin in Irods, just into a particular folder as an automatic configuration file that any configuration changes are picked up on the fly. So try and make that as easy as possible so you never have to restart Apache if you don't want to. One part we have as services is kind of based on the Google idea. If you can, like a keyword parameter, so say you go to a Google search and you type something in, it will go away and do an image search, videos, news, and a web-based search. So we try and have that as the idea that a general search term. So I'll go on to some of the services and finally we get to some Irods. So what we've done is, the first one we've done is taken the idea of searching the ICAT, the Metadata Catalog, and we've exposed that as a Grassroots service, and we try and make it so that people can see all the metadata keys along with all their associated values, and also do a global value search across the entire system. So we've got a list here. So this is taken from one of our example sites, and we've pulled in some particular data, and we've got a list of the keys, and then a drop-down list for each one, the list of the values that are there. But I mentioned about the global keyword search. We also have a search terms thing. So part of the metadata search service is you can type in any sort of substring, and it will go through all the keys and through all those values and try and find matches and pull those back. So the idea being that you might be looking for, say, a particular term, but you don't know what metadata key is associated with. Well, now you don't need to, so we can pull that back. Another thing we've done is we've taken the thoroughly excellent DAVRODS project by Tom and Chris, somewhere up there. That's an Apache module for allowing web data interface to Irods. So it's great, we like that. And what we've done is we've customized that to add some new functionality from the web-based side. So we've taken the themable listings, and I'll show an example, but this is kind of analogous to model to index, which is an Apache module, but also we've exposed the display of metadata and also the searching of the metadata as well. And as well as that, a lot of our data, we're an open data institute as much as possible. So we've created the ability to have effectively public users. So in much the same way that you might have public FTP listings, we try and do the same thing with our Irods instance. And we've got a URL there with an example site. So we have the idea that you can add into various different sections on the HTML page. You can configure this for DAVRODS, so you can add in what goes in the HTML head, what goes above the listings, below the listings, and file type icons and so forth. So this is an example we've got here. And as well as that, we have the ability to, for each item, you can click on a little plus icon and it'll expand and show all the metadata key and value pairs for each object. And each of those metadata key value pair listings are a clickable link. So if you click on those, you can pull back all the items that have got those. So another service we have, which I mentioned earlier, is BLAST. So BLAST is really common in the bioinformatics world, and it's a way of effectively looking for sequence similarity between biological sequences. So this was the first Grassroots service we put live, and that was November 15, and since then we've run about 12,000 jobs, so it's been really successful. It uses our high-performance cluster back at EI or NBI, and one thing we've added to this is the idea of having semantically marked up content as well, so the ability of taking some of the ontologies that I mentioned earlier and taking some of that data and marking it up so that it can be reused by other services. Another one of our services is a field pathogenomics service, and this is a collaboration with an academic on site called Diane Saunders, and it's primarily for breeders. And what they've done is they've taken samples across the world of different pathogens, so different diseases in wheat, and they've taken the location where they found them, the time when they found them, and they've checked them for what genetic traits they have, and so forth. So we've turned that into a map-based tool. So you can see here we've got an example of how many samples have been taken in various different countries across the world. And you can flip between, for a genetic view, so this is what different genetic traits, they're separated into different groups, and you can see little charts of how many there are of each different type. And we have the ability to display it all as a data table, so if you prefer having a text-based view, you can, and that's all globally searchable, and the ability to refine it to a particular data range or a particular map location. And that's one. So I guess what we're going to go on to next is one of our goals is more Irods integration. We quite like the idea of any services that run, if someone logs in with their Irods username and password, putting that onto that Irods share, and using the metadata to effectively store the parameters that we use to run that service, because quite a big deal for us is the idea of reproducibility. So the idea that if you run a scientific experiment and you get certain results and you publish a paper, you can actually publish, here's how we ran it, here's the parameters we used, which version of the software and what data we used. Because in terms of other researchers, it's quite frustrating if you see an excellent paper and you think, yes, and then you can't reproduce the results. So that's something we're looking to do. And we're also looking at federation between so there's Irods Federation again, with lots of our sort of partner institutions, and we're working through that, along with more services. So these are more scientific services, but again, we're happy to take on anyone's other services. And then finally, I'd just like to thank some people. So we've got our partners at the University of Bristol, so Paul Wilkinson and his team, and the team in France, a John Innes Centre, which is a similar partner institution to us, and there are lots of people in our group. And our source code is available on GitHub. Everything we do is open source and open data, so you can go and grab it, do what you like with it. And we also have a portal where people can browse and test. And thank you. Any questions? None.
No, there's got to be one. At least one. What was the most challenging part of adding Irods to all of that?
Probably our learning curve, I'd say. We certainly, right from the outset, Irods was, this is what we want to use for our data, because the whole idea of having data integration is you've solved the problem for us, so thanks, we didn't have to write now.
Sure.
Take it back. Yeah, just you. In terms of writing, say, for instance, the metadata service, I'd spent quite a lot of time having to dig into the metadata catalog to work out how you get from, say, a metadata attribute ID to the data and so forth. But that's, once it's done, hopefully I can do it again. Because I use the genQuery interface, so very happy with that query arrow I did. I don't have to rewrite my code, so thank you. But yeah, right from the outset, it's been our goal. So the more we move forward, I mean, the DAVRODS thing is a big deal for us, so that we've now put a load of our data live using DAVRODS. So it's hosted on an Irods system. It's kind of it's also trying to prove, you've got like to prove to the rest of people in the institution, there's some added benefit to doing this. There's added benefit to adding metadata to your files and so forth.
Yeah, because you can see it. Yeah.
Exactly.
So are you coordinating? Is that work that's going to make it back into?
Yeah, I'm going to chat to Chris and see if we can make a pull request. Yeah.
Excellent. Anybody else? Yeah. Uh-oh.
There's the man.
Here comes the microphone.
Hi, Chris.
Hi. Great work on
Thank you.
on everything, and nice to see you working on DAVRODS. We'll talk about that in maybe at lunch.
Absolutely.
Small question about anonymous access.
Mm-hmm.
Did I understand correctly that you have a way of making files available via DAVRODS without a login?
Yeah, so what we've done is it's a sort of two-phase approach. So on the Irods side, and these are the guys to talk to because I can't remember what I typed in, but made it so it's publicly available, so readable by everyone. But on the back-end config for DAVRODS, we've added a couple of keys for default username, default password. So if you set the authentication or the authorization to be none, it will just automatically use those. So we've got a public user, and every file that the public user can see is automatically what the people will get.
Right, so you have a different DAVRODS instance for that, or?
No, it's the same one.
Okay. Thanks.
Cheers.
You can throw it back, but coming forward is trickier. Anyone else? Not a chance, right? Okay. Thank you. Where's my agenda? All right. Thank you.